Okay, this is the solution where you need to see every step. So your goal is to find the force on this charge, the 3 microcoulomb charge. You have to look at every pair of charges. So first let's look at this one, the 3 and the 4. They're positive, so there's a repulsive force, and therefore it's acting in this direction. I'm going to call that one F1. And then you have to look at the other force acting on the 3 microcoulomb charge. It's between this one and this one. They're attractive, so it goes this way. And I'm going to call that F2. And then right here you can kind of tell which way F total points, because you can now draw F1 like this, and then slide over F2 like this. So the resultant is like this. I'm going to call that F total. And your job is to figure out the angle of F total. Oh, by the way, until you actually do the numbers, you don't know whether it's like this or like this. F total turns out to be more like this. But you don't know that yet. Okay, so what you have to do first is figure out the magnitudes of these forces, so you use Coulomb's law. So the basic form of Coulomb's law looks like this. And so let's do the F1 first. So it's going to equal K, Q1, I'm going to call Q1 the 3 microcoulomb charge, and Q2 the 4 microcoulomb charge, divided by the distance between them squared. Don't forget to convert to meters, and you get that. You don't have to plug in the numbers just yet. Sometimes if you wait, you'll see better what's going to happen. Okay, now then do F2. F2 is going to be between the 3 microcoulomb charge and the minus 3 microcoulomb charge, but you're going to take the absolute value of that and divide it by the distance squared. In this case, for this problem, I did multiply everything out, so you can do that. So you know that K equals 9 times 10 to the 9th newtons meters squared over coulomb squared. So when you plug everything into here, you're going to get 9 times 10 to the 9th. And don't forget, micro means 10 to the minus 6. And you're going to get that. And when you multiply it all out, you should get 43.2 newtons. Okay, you do the similar thing for F2. I won't write it all out, but you should just pause the video and do the whole thing. And you'll get 50.6 newtons. Okay, those are the magnitudes of the forces. So now what you have to do is add them vectorially. And to do that, you have to be able to see the angles. So one thing you notice is that this is a 3, 4, 5 triangle, and it's handy to remember that the angles are 37, 53, 90. But if you can't remember that, then you want to use your trig functions to figure out some kind of angle. So let me redraw this picture. This is the 4 side, 3 side, 5 side, and you can pick any angle you want. I'll pick that one, but then you can write some kind of trig function to figure out your theta, and here tan theta is going to equal 3 over 4, and that should give you theta equals 37 degrees. So then obviously the other angle here is 53 degrees. Okay, so knowing that, you're now going to find F total. So F total is a vector, so it's equal to F1 vector plus F2 vector. So let's first write F1 vector. So you have to look at your picture, and over here, that angle that I just drew is theta. So the x component of F1 is F1, which we know the value of, cosine theta, but it's pointing in the negative x direction, so you have to put a minus there, I hat, plus f1 sine theta, but that's pointing in the negative y direction, so you have to put a minus j hat. Okay, so I just wrote f1. Then what you have to do is write f2. f2 is a lot easier because it's pointing in the x direction. You have f2 I hat. So at this stage, what you have to do is just group together all the I hats and all the j hats. So put all the I hats together. And then put all the j hats together. If you want me to put in the numbers, I will do that. So f1 is 43.2 cosine 37 plus 50.6. So that's a number you can put in. That's something you can put into your calculator. Minus f1, which is 43.2 sine 37 j hat. So you take that and you stick it into your calculator. I'm going to move the paper up like this. And what I got was ultimately 16.1 I hat minus 26.0 j hat. And these are in newtons. Now what you have to do is figure out the magnitude of the vector. So the magnitude of f total equals the x component squared plus the y component squared, all square rooted. So in this problem, it's going to equal to 16.1 squared plus a negative 26 squared, all square rooted, and that should come out to be 30.6 newtons. To figure out the angle, let me switch to a new paper. Okay, so you have to recall. Let me rewrite f total over here. F total is equal to 16.1 I hat minus 26.0 j hat. Now what you have to do is kind of draw that. So it's a little bit to the right and it's a lot down. So therefore F total is over here. So you've got 16.1 to the right and then 26.0 down. I happen to prefer to write positive numbers. So I'm dealing with lengths of a triangle. Okay, then you have to decide which angle do you want to calculate. It's your choice, but this is a typical one. I will call that phi. And so what you do is you say tan phi equals 26 over 16.1. Stick that into your calculator, and you get phi equals 58.2 degrees. And now you look at your picture, you can see that the resultant vector is south of east. And now you have done the whole problem.